So the second part of this review is where I solve some of these equations. So let's go ahead and take a look at our first equation. We can see that the LCD in this first equation is just going to be 20x. So I can clear out these fractions by multiplying every single term here by that LCD of 20x. So when I do, the first one will cancel down to 5, and 5 times 5 is 25. The second cancels down to 10x. 10x times 3 is 30x. The last one cancels down to 4, and 4 times 7 is 28. Moving this 25 to the other side, I get that 30x equals 3 and x equals 1/10. Of course, it's important that I check that back in the original equation, but if you do check it, it does work out. The next one over, very similar. I have to multiply by the LCD. In this case, my LCD is my only denominator, which is just n. N times that first n is n squared. The n's will cancel in the second term, leaving me with a -5, and then I'll get a 4n here. So why is this problem different than the first? Well, the biggest difference is that now I have a quadratic. So we have learned how to solve quadratics by setting them equal to 0 and then factoring. So here I have n squared minus 4n minus 5 equals 0. When I factor that, I'm going to factor it into n minus 5, n plus 1. This gives me two answers of +5 and -1. Again, I should check these answers, but both of them do work. So that's how that particular equation is solved. With 11, it's ever so slightly different. Again, I could do the LCD thing, but I could also, because this is a proportion, just run cross products, which I think is a little bit easier. So when I multiply 3 times 3n plus 11, that's -3, sorry, I'll get -9n minus 33. -2 times that denominator gives me -8n plus 2. I'm going to move this 9n to this side, and I just get an n. I move the 2 to this side, and I get a -35. And again, that answer should be checked, but it does check, so that answer is n equals -35.